Welcome back to this machine learning series. In the past few videos, we have looked at different types of machine learning and understood why data is more important than algorithm. Now let's think about a situation where consider an exam where we get to receive a small paper, and there are three different set of papers for the same, like set 1, set 2, set 3 papers, where a different set of students might receive this different set of papers, right? So in machine learning it's the same way, where there might be multiple different sets of data that a model gets to train with. So let's say if a model memorizes one and loses its performance on the others, it definitely requires some correction on it, right? So that's where training, testing, and validation data sets come in handy, right? So a thought or a question for today is, why can't we simply train a model using all the data and then test it using the same data, right? Do post your thoughts. I would like to hear, even though we talk about it in this video. Okay, so why testing and validation matters a lot. So training errors aren't alone enough. So model may overfit or underfit certain training sets and also perform poorly on unseen data. Right? Validation data set helps us fine tune the hyperparameters and also create a best model. The test set gives a final output, an unbiased estimate of the performance before having to release it. Here, a train test split. This is a simple approach where we can have three portions as a test data set and 70% of it as a training data set. And here is a simple example on how a data set performs with training samples and also having to split test samples like out of a 150 samples. And yeah, this is a simple code snippet. So now let's think about cross validation. So splits the training data into several folds, right? So let's say we get a set of data like the samples of 120, which is close to 0.6% of the initial data set. But yeah, consider a 30% to be a trained a validation data set. And the best way to utilize validation data set is through cross validation technique, where the there are there is folds defined. For example, random states is given as 7, so there might be 7 different folds of data, and one of them might be used as train. A large portion of it might be used as 70%, or so might be used as uh, train dataset, and 30% might be used as validation dataset. And here we are also seeing the validation scores for the same, right? So there are four different results as you see here, and we get these accuracies for the same, and average out of them would be the cross validation result. This would be a lot more beneficial before we put together an actual machine learning project before it goes to test dataset, right? So cross validation is kind of an important to really analyze or still predict the machine learning response to unseen data, right? So that's about uh, cross validation dataset. And finally, with test dataset, we get to understand the model's performance completely based on the unseen data. always know that a good machine learning model doesn't memorize the training data or generalizes any common data, right? So that's the whole idea with all these data splits that we are doing. I hope this video helped you understand training dataset, validation dataset, and test datasets in a machine learning project. We will look at uh, the two most common problems like classification and regression in the next video. We will build simple Python scripts or maybe small demonstration of how charts will look like. We have already looked at different types of machine learning systems, so that's a small portion out of it. By the end of the next video, you'll be able to understand some sort of an approach of classification and regression works. Do not miss that video out. If you found this video helpful, please like, uh, share, and subscribe to this channel. And do share this video to anyone that's interested in learning machine learning. Thanks for watching. See you in the next video.